Hello to everyone, I hope this channel find you well. If you are new to this channel, please right now click the subscribe button.
I will say good morning to everyone, and this is our 7th meeting from the teams, and today we are going to explain about coordinate and projection, one of the important part of the geographical information course. But before that, I want to draw your attention to one of the typical mistake. Maybe you do it also, I'm not sure, but it is very important, and that's why I want to show it for you. You remember, this is our previous homework. At the, I think, third lecture, or yeah, I think it's third lecture or fourth lecture. Anyway, we are speaking about the quantitative qualification, quantitative classification, not qualification. We are speaking about the symbology and quantitative classification. You remember that we are responsible to put our number, our quantitative value, into the certain class. For instance, 5 class, 6 class. You remember I gave you a formula, but later I told you that GIS do it automatically and you don't need to deal with that. But look at this one. This is not classified. When we are asking a legend from you, we are looking for some classification, a certain amount of the classification, 5 group, 6 group, according to the computer calculation. But this is not a correct legend. If you want to deliver something like this, it is better, instead of this one, use a label here. For instance, this color, if it is this one, you can just put the label on it. You can just say 11,270 something. Instead of such a long legend, this is meaningless. This is not considered at all as a legend, because there is no meaning on it. You just say this color is equal to this number, so it is better to put it here, and this is result in confusion. So it is better to not, it is better, you must, if you want to use a legend, provide a proper classification or symbology. You need to make it in a class. For instance, from, let's say, 500s up to 1 million is one class. From 1 million, let's say, to 5 million is another class, and then accordingly up to 11 million, which is this one. So you need to put this class accordingly. So this is absolutely wrong, and if you want to go in this way, don't use legend, put a label. And second things, we ask you to calculate the population density. You remember from previous course, we ask you, first you need to calculate the area, then divide area to the population. This is a process, and you need to do a few steps until you achieve the population density. And we don't want you to just put a population here, because this is a population, and present is as it is. Okay, this is not our let's say requirement. Okay, please be aware about this issue, otherwise you are not meet the, let's say, requirement of the assignment. This is a very important thing that I think it's better to tell you. The rest, I didn't see anything wrong, except this one. This one is very typical in most of your submission. Not all of you, of course. If you are not in that submission, you don't need to take it into the consideration. This is about this part. Anyway, before I am going to start, is there any question, anything that you want to share, anything that you want to ask? Okay, seems that there is no question for this moment. And please, there are some of the students still did not submit their assignment. If there is something related to the assignment, for instance, if you have problem with installation of the program, or if you are not understanding at all, please write to me. We can find a solution for it. Don't leave it for a last minute and last day, because it will be definitely difficult for you and difficult for me. So if you have any problem about assignment right now, it is better to tell me, and I'm tell you always, consider me as your friend. We can solve the problem. Of course, if the problem is related to our course. But of course, if anything else that I can help you or I can give a suggestion, I am here to do my best. For those who still did not start the assignment, please start or get in touch with me in order to meet the end of the course, the requirement for the end of the course. So as I told you, this session in this course, we are going to, let's make it big. I think it's fine. Yeah. Now I think it's fine. This session, I'm going to speak about the geographical coordination system and especially raster coordination system. You remember GIS, it's very simple. If we say that we have a geographical, we have information, and we have a system. We learn almost the information database and how we can work with the system. Now we are going to the geographical part of the course. For a geographical purpose, you know that we have a spatial data. You remember we speak that we have a spatial data, which means that reference by X and Y and of course Z into the real world. You need to help the people to find their way with use of the geographical coordination. The very simplest one is a GPS, like a global positioning system. But let's start to see how GIS, how geographical projection and coordinate work, and what is coordinate and what is projection at all. First of all, in a very, let's say, brief, we have a geographical coordination system, or GCS. This system helps us to define any location in a three-dimension, let's say, on the spherical surface of the Earth, with use of the latitude, longitude, and center or core of the Earth. So we have a longitude and we have a latitude, which is turned, and you know that we have a equator, which is passed from the center almost, and we have a meridian, which is passed from the Greenwich. So we have a north latitude and south latitude, and accordingly we have a west to east longitude, and the point could be able, according to the, let's say, 0, which is the center of the Earth, we are able to provide a location or provide a guidance for those who wants to find their way. It is very simple. You almost definitely know it from your secondary school or even before. But why it is important and why we need to know it, and how geographical coordination system shape. Let's start with it. As we say, geographical system, coordination system, we consume the Earth as a, let's say, ellipse, like this red one. Okay, this red one, we consider our Earth as a, let's say, absolute and correct ellipse. However, we know that our Earth is not that much, let's say, feet on this ellipse, because we have some hilly part, like a mountain, we have some valley, we have a sea. So everywhere cannot be feet accordingly. That's why they are start to think for each continent, for instance, for a, let's say, even for each country, actually, start to assume according to the country topography or that region topography, they start to assume a new ellipse which is better fit for that circumstance. For instance, this part, this, let's say, particular part of the Earth, imagine this blue one, dark blue one, is our geoid or Earth surface or our real Earth. For instance, to find a better fit for this part, you can use a small ellipse for this part. Even for this part, you can use another ellipse, very smaller one, to fit better to this part. Okay. Why this is important now? Why this is important? As you can hear, for instance, still this green one is not correctly fit this blue in this corner. So when this is not correct, we will face with a distortion. Okay, we will face with a distortion. For instance, look at here. In let's say, if we use the red one, we will see that our point x and y is equal to this number. But if we use the green, we will get another number, which means that we will have a distortion. So we need to use a better coordinate system for us in order to minimize this distortion. We have a different, let's say, coordinate system. The typical one is a world geographical system. For instance, this red one, which is bestly fit for an entire world. For instance, for a different location, for instance, for a Turkey, in a Turkey they are use ITRF 96. In a North America, they use NAD or North American datum, which is best fit, let's say, for that continent. Okay, this is about the coordination system, how the coordination system work. But we have another terminology, which is a projection. What is a projection? Let's go to the projection. Definitely you remember, or you hear at least, when you want to, let's say, distribute an orange peel into the flat surface. Maybe you saw it, or definitely you heard it in your school. Imagine our orange is Earth, look like Earth. You see there are some continent on top of it. So in order to, let's say, distribute this orange peel into the flat surface, you need to have some cut. Okay, you need to have some cut. After you put this cut, you are able to put or you are able to flatten without too much, let's say, stretching, or without too much distortion. Of course, you are able to put a different cut from a different place, but this one, let's say, have a less, let's say, distortion, or less amount of the stretching or squeezing. So this is about this. This is very simple. What does the projection means? Projection means that when you want to project a sphere surface into the flat paper or transfer it to the drawing. But what happened in the reality? Definitely you saw this map. Okay, definitely you saw this map in the wall of the everywhere. The distortion problem is actually the projection. We have a different projection. So if the projection is not fit for our place, we will face with a different problem. According, for instance, this projection, the North Pole and the South Pole stretch too much. Look at the Greenland. You see, it is as big as Africa, even bigger than the South America. But in reality, this is that much big, as you can see in down. It means that in our world as an architect, if you use a wrong projection, if you use a wrong coordinate, your drawing will not fit into your land. Okay, either it's bigger than your land, either smaller than the land, which is not correct. Therefore, you need to use a correct projection and correct coordinate system, especially if you are start in a, let's say, professional job in your reality. As you can see, there are many global projections. This is another type of the cutting. Okay, for a different purpose or different accuracy and different continent, you need to use a different cut. As you can see, look at the Greenland right now here. The real size of the Greenland according to this cut is this, which is very smaller than the Africa. However, here it's as big as Africa almost. So this is important. Now let's go to the real manner. When we transfer a projection, imagine this curved line, which is a start from I1, I in this one, up to capital E. Imagine this is our Earth. So we want to transfer our Earth to the paper. We want to transfer our, let's say, Earth into the paper. This one is our paper, this surface line, this straight line. If we transfer it, or if we project it Okay, we will face with a different scenario. The first scenario, imagine you are owner of the A to B parcel land. You have a land in reality, and you have a document of it. It is, let's say, 100 square meter. Now onto the paper, after they transfer it to the paper, which is equal to the small a and small b. Your land is smaller than reality right now. You have 100 square meter, but in the paper, when you put your ruler, when you start to calculate, it's look like that you have a 800 square meter, okay, instead of 100. Sorry. Another scenario, we have another also scenario here. Imagine you are owner of the land, which is start from a capital D onto capital E. But on the map surface, it is appear very bigger than reality. You see, the small d up to small e is too much longer than this distance. So this is the big problem in reality. Almost we can say that the B to D is a good distribution, less distortion. That's why we are using projection. So instead of one big line like this one, like E and this one, it is better to use a many small line in order to better fit our sphere, like this one. If you put a very small cut, you will get a better result. But with a big cut like this one, you will see many problems accordingly. So we have a different projection: cylinder, conic, azimuthal. Each of them have some advantage and disadvantage. So based on the different continents, you can use accordingly which one is a better fit for you. But the most typical one, which is based on the central meridian, we use this cylinder one. This is a cylinder, let's say imaginary transverse cylinder. We call it as a universal transverse Mercator, because this is fit for actually not fit, but this is acceptable. Again, we have this problem with North Pole and South Pole. So for a North Pole and South Pole, it is better to use either conical or azimuthal. But for almost center, let's say in this area, it is not bad idea to use a universal transfer Mercator, or from now on UTM. Of course, we have other let's say projections such as Lambert, such as Albert, but in this course we are mainly working with a UTM. But just be aware what we are doing and what is the main issue. After let's say we use this projection, our entire world divided into the 60 column. You see, start from here, which is column number 1, up to end, which is column number 60. At the middle we have A and B part, and of course this is equator, which is passed from here, and we have a 90-degree down, 90-degree top. Okay, this is about this part. In order to find which number is suitable for you. Imagine right now we are in Cyprus. Okay, Cyprus is almost here in the Mediterranean Sea. You can see it. So for us, which column is good for us? It is column almost 36. Okay, if you follow this column number, the 36, it's almost fit for us. And another issue, the Cyprus located in the north part. So our coordination become 36 and projection based on the UTM system. Okay, this is how we find. For instance, if you are let's say if you are in Saudi Arabia, imagine Saudi Arabia, it's almost here. The Saudi Arabia, it's 39, which is located almost in 39, and again in the north part, which is 39N. Or if you are doing some business in Spain, which is almost here, it is 30, which is located on the 30, and again north. So this is how you are able to give address and use this projection. So you will see that you will say that we are using a world geographical coordination, which is WGS 84. The numbers are related about the convention, which is 1984. WGS, and we use a projection of the UTM, Universal Transfer Mercator, and zone for Cyprus 36N, or for any other place. Accordingly, we use that number. And this distribution, this part almost here in the Caribbean Sea, it is here. We have the place that primary meridian and let's say equator meet each other. We call it a null island, and the null island considered as a 0Z or 0 altitude, which is considered as MSL or mean sea level. Maybe you saw it in some of the drawing. At the very, let's say, down part of the entrance, when you put your level code, they write that MSL equal to, let's say, 13. Then on top of it, you say that from now we consider this 13 as a 0 of our project. And as you can see, they put a buoy in this location of the null island. So in this buoy, N is 0, S is 0, and Z is 0. It is a 0, 0, 0 or null island. This is about the lecture of this part. I try to give you the necessary information. Is there any question about this part up to now?
No, I guess it's clear.
Yeah, it's very easy. You don't need to stuck on it.